Salutations, mini mathematicians. Thanks for joining us. We're going to be working on 4.1b lesson, which is model and solving one and two-step equations. Your notebook purpose is to undo addition and subtraction first to isolate the variable, verify using the equation, and we're going to be doing this on the printed lesson with this video. You're going to have reflection number 2. So let's go ahead and get started. I do have a calculator here and some colors to use for these models. So we've been modeling equations and expressions with these tiles, 1x, -1, -x, and of course also thinking about those zero pairs. So let's read the directions. It says for algebra, use algebra tiles to model and solve the following equations. Be sure to draw a horizontal line to separate your steps. So show your algebraic process in the right column and write all fractional answers in simplest form. Be sure to check your solution. So when we check, that's another word for verify. So remember, we want to make sure that the value we find makes the equation true, meaning it is a solution. And just over here, just to be sure, I'm just going to write algebra, so we remember to solve using the algebra over in this column. Okay, so our first equation is 2x minus 5 equals -9. To make my modeling more efficient, I'm going to rewrite this as 2x plus -5 is equal to -9. This way, I can draw in two positive rectangles on the left, 5 negatives, and you can just color those in, 1, 2, 3, 4, 5, and this is equal to 9 negatives. So I'm going to show 3 groups of 3, because sometimes when you are modeling, grouping them together helps communicate clearly. And that is one step. So we're going to draw that horizontal line. Always want to start with what is given. So our next step is going to be to isolate our variables. We're going to rewrite everything we have, thinking about what are we going to do to isolate our variable. We want to get rid of these 5 negatives. So I'm going to draw them in a line because we all know we're going to be adding 5 positives to both sides. And we're going to redraw these 9 negatives on this side. These are equal to one another. Okay, so again, our goal is to isolate the variable. How are we going to do that? Inverse operations. So here, to undo 1, 2, 3, 4, 5 negatives, I'm going to add 5 positives to both sides. And then what do we have left? And remember, we want to be thinking about our solving process as we do this. So I know I'm going to have 2 x's left over, so I'm going to stack them up and down so that I can make them into groups, split them into groups, equal groups. So here I'm going to end up with 4 negatives left over. 1, 2, 3 cancels out, and these 2 leaves me with 4. So I'm going to group those together in 2 equal groups so that in this next step, what we can do is we can split these into groups. Remember, we use kind of those oblong potato blob shapes to show groups. And what do we have left at the end? We have 1x is equal to 2 negatives. Okay, so let's show this with the algebra. So the first thing we did is we had our original given. So we had 2x minus 5 is equal to -9, or 2x plus -5 is equal to -9. From here, we had 2x minus 5 equals -9, or 2x plus -5. And what did we do to both sides? We decided to add 5 positives here, making this a zero pair. And so from here, what do we have left? Well, we had 2x is equal to -9 plus 5 is -4. Oh my gosh, it's matching our model perfectly. And what did we do in this step? We broke this into 2 groups. So we could say dividing by 2, or the multiplicative inverse of 2 is 1/2. So we took a half, or broke each side in 2 halves into 2 equal groups. And from there, you got your answer of x is equal to -2. Yay! So now we're going to do our verify step to check if we got this right. And for this first example, we're going to verify with the equation and the model. So we're always going to start with the original equation, 2x minus 5 is equal to -9. And from here, I want to verify if x is equal to -2. So everywhere I see an x, I'm going to put an empty parentheses. I'm going to plug in -2 for x. Now, when you verify in an equation, you do no inverse operations because there's no variable to isolate. All we're doing is simplifying. So from here, multiply first. 2 times -2 is -4. And then -4 minus 5 is -9. And yes, -9 is equal to -9. So that's a true statement. And Chucky goes, you got it right. You got it right. Using a model to verify, we would draw what we originally had. So 2 rectangles, 5 negatives, 9 negatives over here. And inside each one of these, we would put 2 negatives. So that on our next line, we would see that this is 5, 6, 7, 8, 9, 9 negatives equaling 9 negatives. So I'm just going to group them similarly so I'm clearly communicating that these are equal to another, meaning it's a true statement. And Chucky says, great job, guys. You got it right. Awesome. So what I'd like you to do is I'd like you to pause the video and finish 2 and 3 on the next page. Go ahead and finish 2 and 3. I'll help you out getting 2 started. We are going to rewrite this as 7 is equal to 3x plus -2. Okay, go ahead and pause the video and we'll go over it in just a second. Okay, let's take a look at how we did. So number 2, the first thing we did is we rewrote it. And we had 7 positives equal to 3 rectangles adding to 2 negatives. And so the next thing you did is you added 2 positives to both sides. From there, you split them into 3 equal groups, getting you to 3 is equal to x. And of course, we want to rewrite that as x is equal to 3. Looking at that with the algebra over here, we start with what's given, and you could have written it as 7 equals 3x plus -2, or just 7 equals 3x minus 2. From there, we had to add 2 positives to both sides, making a 0 pair over here. From there, we get 9 is equal to 3x. We took a third of both sides. The multiplicative inverse of 3 is 1/3, getting you 3 equals x, which of course, x is equal to 3. Verifying either with your model or with your equation, we both get true statements. Remember, you do not do any inverse operations with your verify. You are just doing order of operations. Awesome. Let's take a look how you did on number 3. Number 3, the first thing we did was we modeled the equation that was given to us. -5 is equal to -3 plus 2x. From there, we rewrote this and we said, how do we isolate our variable? We had 3 negatives we needed to get rid of, so we added 3 positives on both sides, resulting in 2 negatives equal to 2 x's. From here, we had to split this into 2 equal groups to undo having 2 x's. We just want 1. -1 is equal to x, which means x is equal to -1. The corresponding math, and notice we write each step in a box. -5 equals 3 plus 2x. We start with the original. Then we added 3 to both sides. We always want to get rid of our circles before our rectangles. So undoing -3, we add 3 to both sides, resulting in -2 is equal to 2x. We took the multiplicative inverse of 2, which is 1/2, or split both sides into two groups to get -1 is equal to x, which means x is equal to -1. From here, taking a look at the verify, we could have plugged in that -1 in for x and gotten a true statement, -5 equals -5. Or when we verified with our model, all right, the original model, plug in what you got for x into your rectangles, and we end up with a true statement. Good work, mini mathematicians. Okay, let's keep going to the next page. So taking a look at this next one, this is a really interesting model here, really interesting model. We have 3 plus half of an x is equal to -3. So taking a look here, we're going to have 3 positives, and we have half of a positive x. So we're going to have a ghost box. A ghost box, so it's like a whole rectangle, but we're going to show that we only have half of it by giving it just some dashes. And we're going to circle that we have a half of it instead of the whole thing being there. So 3 positives plus half of an x is equal to 3 negatives on the other side. 1, 2, 3. Don't forget your equal sign. And then that's our first step, is our given. From here, we're going to redraw what we have. 3 positives, half of an x. Show that it's a half by circling just half of it, equals 3 negatives. From here, we want to isolate our variable. So to get x by itself, we need to get rid of 3 positives. So I'm going to add 3 negatives to both sides. And that's one step. What do we have left? Well, now after we made those 0 pairs, we have half of an x left. And we have 6 negatives on this side. Well, I don't want half of an x, I want a whole x. So how many groups would I need to make of this? I would need to make 2 groups. So I'm going to take this and make 2 groups of it. Kind of like duplicating it or doubling it maybe. So that we have this half of an x and another half of an x. Or if we double half of an x, what do we end up with? We end up with a whole x is equaling to how many negatives? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. -12. Okay, let's show the algebra steps to solve this. So first thing we're going to do is we're going to write the original. So 3 plus half of an x, or x over 2, is equal to -3. Rewrite that. And the first thing we did is we added 3 negatives to both sides because we were undoing this +3, making this a 0 pair. From there, we had x over 2 is equal to -6. We need to undo dividing by 2, which is the opposite of dividing is multiplying. So I'm going to multiply both sides by 2. Notice how these 2's cancel out, and I'm just left with a whole x. 1x, or just x, is equal to -12. Ah, our answers match. And I'm going to show the verify, and from here on out, I'm just going to show the verify with the equation. So we call it a verify. You can also just call it a check, or sometimes you might just see me write a check mark like that if I'm labeling where I'm doing my verify. So of course, I'm going to write the original equation always. 3 plus x over 2 is equal to -3. And I'm going to rewrite that equation, but everywhere I see an x, I'm going to put an empty parentheses. So then I can substitute in the value I think this is. Remember, there's no inverse operations during the verify because there's no variable to isolate. So here this is 3 plus -12 divided by 2 is -6. And 3 plus -6 is -3, and -3 does equal -3. Nice. So Chucky's like, you got it right. You got it right. Great job. Great work. Okay, mini mathematicians, I'd love for you to work on 5. Go ahead, pause the video, finish number 5, and we're going to go over that in just a second. Let's take a look at number 5. So this one's really similar, except this time we have half of an x on the other side. So we have 3 negatives equals half of an x plus 2, showing that ghost box of half. From here, I needed to get rid of positive 2, so I added 2 negatives to both sides, keeping it equal. From there, I had half of an x equaling 1, 2, 3, 4, 5 negatives. So I wanted to double that or make 2 groups of it to make a whole x is equaling to -10. And then flip to have the variable first to have x is equal to -10. The algebra starting with what is given, subtracting 2 or adding 2 negatives to both sides to make this a 0 pair. To end up with -5 is equal to x over 2, or 1/2 x. Undo dividing by 2 by multiplying both sides by 2. -10 is x, which means x is -10. We could verify using the equation or the model here. So if you take a look with the model, substituting in -10, notice -10 is the whole x, so I only want to take half of it, which would be 5, and -5 plus 2 gets you -3. Here, using the equation, -3 is equal to x over 2 plus 2. -3 is equal to -10 over 2 plus 2. -10 over 2 is -5, and -5 plus 2 is -3, and -3 equals -3. So you know you got it right. Fabulous. Good work on number 5. Let's keep going and let's do number 6 together. Taking a look at number 6, notice our variable changes, and that's fine. We're still going to use that rectangle to represent this. But I am going to rewrite this because I don't want to put in 4 0 pairs. So we're going to rewrite this as 8 is equal to 2p plus -4. Fabulous. So first thing I'm going to do is I'm going to model this with the 8 positives, 1, 2, 3, 4, 5, 6, 7, 8, equal to, I need 2 positive variables and 4 negatives, 1, 2, 3, 4. And then, of course, so that is our given, our original problem, and I'm going to rewrite that thinking about what my next step is, which I'm going to add 4 positives to both sides. So I might want to group this as 2 groups of 4, or just as the 8. 1, 2, 3, 4, 5, 6, 7, 8. My 2 positive variables, and then my 1, 2, 3, 4 negatives. Again, what's our goal? Isolate the variable. How are we going to do that? Inverse operation. So how do you undo -4? We're going to add 4 positives to both sides. Fabulous. Now let's see what we have left over. We have 2 x's left over because these made 0 pairs. And over here, we're going to have 12 positives. Think about what our next step is. Our next step is to get x by itself, so we're going to make this into 2 equal groups. So how many go in each group? That's right, 6 in each group. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Set these equal to each other. We're going to take those groups. We're splitting it into 2 equal groups. We're dividing by 2 or multiplying by 1/2. So here we can take just one group is equal to 6. And of course, that means x is equal to 6. Oops, forgot one there. 6. 1, 2, 3, 4, 5, 6. Let's show our algebra steps to get here. Write the original. 8 is equal to 2p plus -4, just -4. Write the original again in the next step. and then show if you're adding or subtracting. Here we wanted to undo subtracting, so the additive inverse of -4 is +4, making a 0 pair here. 8 plus 4 is 12, so we have 12 is equal to 2p. From here, the multiplicative inverse of 2 is 1/2, so I'm going to take half of each side, showing that 6 is equal to p, meaning p is equal to 6. Fabulous. From here, I'm going to do my verify just with the equation. That's totally fine if you want to do the model, but I'm just going to use the equation. I find it's the most helpful for me and later on. So write the original, 8 equals 2p minus 4. Rewrite this with parentheses everywhere I see the variable. Go back and plug in the value you think the variable is, and just use order of operations. 2 times 6 is 12. 12 minus 4 is 8, and 8 is equal to 8. That's a true statement, so you know you got it right. You got it right. Perfect. Okay, let's take a look at the next one, number 7. Number 7, I want you to do this on your own, so go ahead, finish up number 7, and we'll go over it in just a second. Let's take a look at number 7 and how you did. Hopefully you paused the video and you're not just copying what I put down. You tried it on your own. Okay, number 7. First things first, we modeled what was given to us. So we have 3 variables. In this case, it's t. 3t plus 5 positives equals to 2 positives. From there, I wanted to undo adding 5. So I'm going to subtract 5 or add -5 to both sides, clearly showing me that I have 3x's equal to 3 negatives. I'm going to break this into 3 equal groups from there to get x is equal to -1. Let's check the algebra steps here. 3t plus 5 is equal to 2. Careful with your t's, they don't look like plus signs. Sometimes I like to give it a little curly Q at the end. From here, I'm going to subtract 5 from both sides, additive inverse. From there, I'm going to use the multiplicative inverse, multiply by 1/3 of both sides to get t is equal to -1. Let's do our verify. Write the original equation. After we write the original equation, we're going to plug in with parentheses -1 for our variable. From there, 3 times -1 is -3. -3 plus 5 is 2, and 2 equals 2. That's true. Checky says, great job, guys. Awesome work. Okay, so we just have a few more models left, and we're going to get into solving these without models soon. So let's take a look at number 8. Ooh, groups, you guys. We've done this before last module. Okay, so taking a look at 8, to start off, I'm not going to need any 0 pairs, but I'm going to need groups. So I'm going to write this as 2 groups. And in each group, what do I need? I need an x and a +1. And this is equal to, on the other side, 8 negatives. I want you to be really aware of how I'm going to show this. I'm going to show this as 2 groups of -4 without the groups, but kind of as rows here. Okay, so this one, I'm going to show a step in this first box just because I know this takes up a lot of space with our groups. What I'm going to do is I'm going to split these into 2 equal groups on both sides. Bum, ba, da, bum. Very cool. Now I'm just going to take one of those groups. So we have x plus 1 is equal to 4 negatives. Ooh, does that make it a little simpler to solve? Little math magic there. From here, I'm going to say that that's one step, just so you can really see it. Now I'm going to rewrite what we have. So an x and a single, x plus 1 is equal to -4. Oh, you guys, I've been forgetting to put my equal sign. There we go. And I want to isolate my variable. How are we going to do that? Inverse operations. The inverse of 1 positive is adding 1 negative to both sides, which results in 1x equaling 5 negatives. 1, 2, 3, 4, 5. Let's look at the algebra that supports this. So if we start with two groups of x plus 1 is equal to negative 8, remember when we first learned distributive property, I called it fancy multiplication? Well, that's because the inverse of multiplication, the multiplicative inverse, is the reciprocal 1/2. So I'm going to multiply both sides here by 1/2. Now, when I do that, this 1/2 just multiplies the 2. It doesn't touch anything inside these parentheses, or else it'd be double multiplying. So after I do that, we end up with just x plus 1 is equal to negative 4, just like in our model, And from there, when we had x plus 1 equals negative 4, we subtracted 1 from both sides, or added 1 negative, making a 0 pair, to end up with x is equal to negative 5. Yay, same answer. And of course, we're going to quickly verify with the equation. So two groups of x plus 1 is equal to negative 8. Oops, got to label it for my verify. Here's my check. Two groups, so I'm going to change those parentheses to brackets. Negative 5 plus 1 equals negative 8, just to clearly communicate. From here, inside here, order of operations, negative 5 plus 1 is negative 4. 2 times negative 4 is negative 8, and negative 8 is negative 8. Yay, true statement. We got it right. We got it right. Okay, number 9. One of the last models we're going to be doing together. Taking a look here, this one's going to be very interesting because notice we are taking away groups. Notice we are taking away groups, so this one is a little more advanced, but nothing that you cannot handle. You're an amazing mini mathematician. So the first thing I'm going to do is I am going to rewrite this as 6 is equal to take away 3 groups of x plus negative 4, just so I don't have to deal with too many 0 pairs here. Okay, so on the left side, we need 6 positives, 1, 2, 3, 4, 5, 6. And on this side, I'm going to need 3 groups, 1, 2, 3. And in each of these groups, I'm going to need 0 pairs of x's and 4 negatives. So I know I'm going to end up taking away an x, and I should have made these groups a little bigger, huh? 4 negatives. So we want them to line up so we can take it away as a group. Oh no, I should not have filled these in. Gotta make them look open. There we go, that's better. And this last one. Okay, so this is step 1. Of course, we still need to take them away. So take away 3 groups of x plus negative 4. So boom, they're gone. Boom, they're gone. Boom, they're gone. Ba-choom, they're gone. Okay, so what do we have left over? We're still going to have these 3 groups, so I'm going to stack them into their 3 groups. So we're going to have a group of these negative x's and positive 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And over here, we're going to have the 6 positives, but of course, I'm going to make them look like they are in groups. Okay, so from here, I'm going to split them into the 3 equal groups so that when I take one of them, I'm left with 2 positives. Oops, don't forget your equal sign. Equals a negative x and 4 positives. Very nice. Very, very nice. Okay, so from here, what do we want to do? We want to isolate our variable, so we need to get rid of these 4 positives by adding 4 negatives to both sides. Excellent. What are we left with now? We have a negative x is equal, oh, you guys, I should have been filling these in, haven't I? Silly Mrs. Barr. I hope you are yelling at your screen. Mrs. Barr, fill them in. Goodness gracious. And over here, we're going to have 2 negatives. So remember, our goal is to isolate our variable. If we have negative x, it's not isolated. So what we're going to do is we're going to flip everything. We're going to take the opposite of everything, multiply both sides by -1. So when we do that, we take the opposite of everything. We end up with positive x over here and 2 positives over there. And our final step, putting the variable in front. Awesome, really good work. Let's show the algebra to support this. Okay, so first step, 6 is equal to take away 3 groups of x plus -4 or just x minus 4. From here, because I have 3 groups of both of these, what I'm going to do is I'm going to divide both sides by 3, which is the same thing as taking a third, right? The multiplicative inverse of both sides. So I'm going to divide both sides by 3 here. Another thing you could do is you can think about that this ends up distributing the -3 to get everything here. So if we take a look at this and we take 1/3 of both sides, we're going to have 2 is equal to -1 times x minus 4. And then we would have to distribute that -1 to get 2 is equal to -x plus 4. From here, we need to get x by itself. We're going to subtract 4 from both sides, making a 0 pair here, and getting -2 is equal to -x. And again, we want to get rid of this -x. We want a positive x. We're going to multiply both sides by -1, taking the opposite of everything to get 2 is equal to x, meaning x is equal to +2. Nice work. Okay, we are going to skip the verify on this one since you've been doing such a good job with verifying. And you're going to do number 10 on your own. So go ahead and finish number 10, pause the video, finish 10, and we're going to go over it in just a second. Okay, let's see how you did on number 10. Taking a look at number 10, so we needed to take away 4 groups of 3 minus 2m equals -12. So I rewrote it as take away 4 groups of 3 plus -2m. So hopefully you made your groups with your 0 pairs. Make sure you have your 3 and your -2 variables next to each other so you can take that away as a whole group, equaling -12 on the other side. So you take those away, and what are you left with? We are left with these groups together. So 1, 2, 3, 4 groups of 2 positives and 3 negatives in each group. And when we take those into groups again, we end up with 2 x's plus 3 negatives is equal to 3 negatives. To undo the 3 negatives, I add 3 to both sides, 3 positives, to get 2x is equal to nothing. There's nothing there, you guys. There's nothing. I guess you could draw a 0 pair there if you want, so that x is equal to 0. So showing the math, we can say that -4 times that. We could distribute that -4. That's one way you could have shown this. Of course, there's the other ways. You could have divided both sides by 4 to begin with. Here, then you could take a fourth of both sides. Either way, you're going to end up eventually with -3 plus 2m is equal to -3. And then add 3 to both sides. 2m is equal to 0. Multiplicative inverse of 2 is multiplied by 1/2 to both sides to get m is equal to 0. your verify, and I would love for you to show this verifying step, please and thank you. Verifying with the equation, substitute 0 in for m, 2 times 0 is 0, negative 4 times 3 is negative 12, and negative 12 equals negative 12. Yes, excellent work. Okay, great work through 10, you guys. We're going to now do these problems without a model. And I want you to verify the evens. So I want you to check your solutions just on the evens for the rest of this lesson since you've been doing such a great job. Okay, let's look at 11 and 12 together. So 11, again, what's your goal? Isolate the variable. So we're solving for x here. The first thing I want to do, how do you undo plus 9 to both sides? You're going to subtract 9 on both sides. When you do that, we end up with 5x is equal to negative 35. How do you undo multiplying by 5? The multiplicative inverse, which is 1/5. So I'm going to take 1/5 of both sides. And when I do that, I get x is equal to negative 7. Like I said, we're just going to verify the evens today for the rest of the lesson. Okay, let's take a look at the next one. So we have 3/4 of a y minus 3 is equal to 9. What's our goal? Isolate the variable. How are we going to do it? Inverse operations. So how do you undo negative 3? The additive inverse plus 3 to both sides. This makes a 0 pair. From here, we'll have 3/4 of a y is equal to 12. And again, it's really important to be showing your steps exactly like this. From here, y is being multiplied by 3/4. So what's the multiplicative inverse of 3/4? The reciprocal, which is 4/3. Notice over here, these 4's cancel out, these 3's cancel out. I'm just left with 1y or y. And over here, if you want to think about cross-canceling, 3 goes into 3 once and into 12 4 times. So we end up with 4 times 4 on top and 1 times 1 on the bottom. So y is equal to 16. And we're just going to do our check right below. 3/4 y minus 3 is equal to 9. 3/4 times 16 minus 3 is equal to 9. Remember, no inverse operations on your verify. Cross cancel, 4 goes into 4 once and into 16 4 times. 3 times 4 is 12. 12 minus 3 is 9, and 9 equals 9. It's a true statement. So yes, 16 is your solution. It's the value that makes the statement true. Yay! Okay, so I'm going to do 15 and 16 with you, and then you're going to do 13, 14, 17, and 18 on your own. So let's take a look at 15 and 16 together real quick before I set you loose. Taking a look here, remember what's your goal? Your goal is to isolate the variable. We have to get rid of our circles before we get rid of our boxes here. So to undo minus 6, I'm going to add 6 to both sides, making this a 0 pair. From here, I have x over 4, or 1/4 of an x, is equal to 1. How do you undo dividing by 4? Multiplying by 4. We can think about how do you undo multiplying by 1/4? Multiplicative inverse of 1/4 is positive 4, the reciprocal. So from here, those 4's cancel out. I'm left with x is equal to, and on this side, 4. And I said we're only verifying the even, so you don't have to verify that one. And from this one on the next one, what are we going to do? Well, we could distribute that 2 first, but notice on the other side, this is also a multiple of 2. So I'm going to divide both sides by 2 first to undo the multiplication to just get n plus 5 is equal to negative 1. Wonderful. From here, additive inverse of 5 is negative 5. Subtract 5 from both sides. There's your 0 pair. N is equal to negative 6. Great job. We're just going to show this one other method just in case. So 2 groups of n plus 5 is equal to negative 2. So what I could have done is I definitely could have distributed that 2 first, and make sure you're writing this method down as well. 2n plus 10 is equal to negative 2. From here, subtract 10 from both sides, making this a 0 pair. 2n is equal to negative 12. Multiplicative inverse of multiplying by 2 is multiplying by 1/2, the reciprocal, and n is equal to negative 6. So again, different method, same answer. Either of the work is just as great. This method just might be a little more efficient. Let's do our check since this is an even problem. And we'll write the original. 2 groups of n plus 5 is equal to negative 2. 2 groups of negative 6 plus 5 is equal to negative 2. Don't lose your negative. 2 groups of negative 6 plus 5 is negative 1 equals negative 2. And yes, negative 2 is equal to negative 2. That is a true statement. So you know you got it right. Okay, 13, 14, 17, 18. Go ahead and finish those problems up, and we're going to go over them as soon as you're ready. So please pause the video. Okay, let's take a look. 13. We should have gotten negative 4 as our answer. Subtracted 3 from both sides to undo adding 3. Multiply both sides by the reciprocal or multiplicative inverse of negative 4, which is negative 1/4. Negative times a negative is a positive. Negative times a positive is a negative. Careful with your negatives there. And I showed you your check even though you didn't have to do it because it was an odd. 14 over here, taking a look, we could subtract 4 from both sides, undoing that positive 4, getting negative 2c is equal to negative 12. Multiplicative inverse of negative 2 is negative 1/2. So from there, c is equal to 6. Negative times a negative is positive. Negative times a negative is positive. Or from the very beginning, after you subtracted 4 from both sides, maybe you just took a half, and then you had a negative c equals negative 6, and then you multiplied both sides by negative 1 to take the opposite. Your check comes out true. Awesome. Last 2 problems. Let's do this. 17, first thing I did here is I subtracted 6 from both sides to simplify. First, always undoing the addition and subtraction before you undo the multiplication here. And then I took a third, the multiplicative inverse of 3. To get 2x minus 4 equals 2. Added 4 to both sides, 2x equals 6. Divided both sides by 2 or multiply both sides by 1/2 to get x is equal to 3. And on 18, a little trickier with the fractions, but nothing you can't handle. I rewrote negative 2 and 7/8 as the mixed number, improper fraction. Wrote the mixed number as an improper fraction, negative 23 over 8. I distributed this 1/5 and 5/8 to get 5/40. 1/5 times negative r is negative 1/5 r. From here, I'm going to subtract 5/40 from both sides. So I rewrote negative 23/8 as negative 115/40 to make it easier for me. So then when I subtract negative 115/40 minus 5/40, I get negative 120/40 equals negative 1/5. Multiplicative inverse of negative 1/5 is negative 5. So I multiply both sides by negative 5 by the reciprocal to get 15 equals r, or r is equal to 15. And my check works out perfectly. Congratulations, mini mathematicians. We are solving equations. Remember, you have reflection number 2. Do your best, be nice to everyone, and I will see you next time.